All right, y'all. So like I said, this is our test 4 review. Well, let me let one in real quick. All right, so today we'll knock out this test 4 review. On Wednesday, we'll knock out our final exam. So let me get us going on this. So question 1, they want us to graph y equals 1/3 to the x. So on this one, I'll just plug it right into my calculator. So let's go look at this graph. And this one will have 4 pictures to choose from. So we'll go to y equals, and we'll put in our fraction. So I'm going to put in my 1 divided by 3, close parentheses, and then my exponent would be the x. Now, if you use the alpha y equals, put into 1/3, you don't need parentheses using the alpha y equals, okay? So y'all, let's graph this. So notice it goes downhill left to right, and it does not cross the x-axis. And it's crossing that y-axis at 1. So we would pick on the 4 pictures. For that one, we would pick, which one was it? B. It's coming down and it does not cross the x-axis. Be careful for D, because D, it does cross over and gets into the negative values. Okay. But yeah, it's going to be the one that comes down, goes across 1 on the y-axis, and then just sort of hugs that x-axis, okay? So number 2 was another graphing one, but this one was the translations. So they're giving us f of x equals 2 to the x plus 3. So in MathLab, it'll say start with the graph of y equals blank to the x. So that's wanting your base here. So my base is a 2. So I would put in my 2. Now don't put the x, because they already have that x there. And then we got to figure out what that plus 3, when we add 3 to the x, what's that doing to my graph? Well, remember, this is going to make it go left or right. And since we're adding 3, that's going to shift the graph left 3 units. Okay, so subtraction will move me right, adding moves me left. Now, on MathLab, to graph it, you have to choose the exponential tool and click on the graph. Once I click on the graph, it's going to open up the box. So since we're moving left, we got to take the horizontal control and move that left to -3. Don't y'all hang on one second. I got to see who just came in.
Mr. Eugene.
Yeah.
Is this the one where the base is important? So we make 2 the base?
Yeah, that's what I was going to say next.
Okay.
Down in the left corner, it's going to say base. And remember, by default, it's got the little e there. Okay, so it's going to have the e there. We need to change the base to match the base of our problem and put our 2 in there. Okay, so once you choose that tool, move it left 3 units, it's going to slide that graph over, and then remember, change that base, okay? All right, y'all, then we get to our word problem about Melissa. So on Melissa's 6th birthday, she gets a $3,000 CD. And it earns 4% interest. And it's compounded semi-annually. So they're saying if this CD matures on the 16th birthday, so it matures on their 16th birthday, they want to know how much money will be available. All right, y'all. So I gave us a formula for this kind of problem, and it was the amount, which is A of T. So the amount at any time T would equal RP times 1 plus R divided by N, all raised to the N times T. And y'all, we got everything we need to put into this. What we got to figure out is how much time passed between the 6th birthday and her 16th birthday. So for this one, our T is going to be 10 years. R is my interest rate. Well, remember, R is 4%. But you need to turn that 4% into a decimal to use it in this formula. So remember, you would move that decimal left 2 units, and that would give us a 0.04. So we got N and T now. We got R and T. We need to figure out N. Well, N is the number of compounds. So what y'all got to figure out is, what does semi-annually mean? So what would y'all put for semi-annually on that one?
That's 2. Is that 2 months, 2 weeks?
Well, that's 2. There you go.
Okay. Mr. Eugene, right there where you got that P where it says P parenthesis 1 plus, is that an R over N?
R over N.
Okay.
That's this R we're finding, this little interest rate here, okay?
Okay, I would just make sure that wasn't a T. Okay.
So we're finding the amount after 10 years, since that's what our T was. So our principal was our starting amount, 3,000. And then we got 1 plus R, which is 0.04, over N, which is 2. And that'll be raised to the exponent 2 times 10, since that was my N times T. Now, we got to round this 2 decimal places, like cents. So, y'all, I'm just going to go to my calculator, punch that in, see what we get. And remember, she started with 3,000, so this has to be more than 3,000, okay? All right, so let me get off the graphing. So I had 3,000 parentheses 1 plus my 0.04 divided by 2, close those parentheses, and then our exponent was what we have, 2 times 10. Whoops, I don't know what I did there. All right, let me start over. I hit something wrong. So 3,000 parentheses 1 plus 0.04 divided by 2, close parentheses, and then my exponent was 2 times 10. Or y'all, you could have just put 20 there instead of writing 2 times 10. You could have just put the 20 there, okay? So let's hit enter. And we're rounding at 2 decimal places. So that's 4,457. Point, let's see, 2 decimal places. So the 4 has a 2 after it, so I'm going to keep that a 4. So that'll be 4,457.84. So that's what you got to be careful on this test. So much of this test has its rounding stuff. So watch out for if they want 2 places, or you'll see later we got to go 4 places on a lot of stuff. All right, y'all. Now we're about to find a lot of logarithms. So number 4, find the logarithm. Which means find the exponent. Remember, logarithms are exponents. And this one has a log base 10 of 100. So I'm looking for the exponent that I would raise this 10 to turn that 10 into 100. So basically, how many times you got to multiply 10 times itself to equal 100? And that'd be a 2, right? 10 times 10 is 100. So the exponent would be a 2. But y'all watch this. We got that log base on our calculator. All right, so let me clear this. So if you hit math and the arrow all the way down to log base, you can put this problem in just like it looks. So log base, put in a 10 for the base, put in 100 for the result. And y'all, when we hit enter, that exponent is a 2. All right, so let's see, 5.
Mr. Eugene, how did you get the, hold on. How did you get that to be you hit log? Did you go to math to get the lower?
I went to I went to math first.
Log base. No, that's not what you did. Okay, I'm listening.
And then go right down to that log base, okay?
Okay, math, and then go to log base. Oh, because it's not going to appear as log base. Okay,
Right.
got it.
Okay. And 5's doing the same thing, but y'all, this is log base 3 of 3 to the 4th. Now we had a property that said if we got a log base that matches that log base raised to an exponent. So if this base matches the base raised to an exponent, the answer is going to be the exponent, which is 4. So y'all watch this. We can punch that one on there. Any of these logs, we can punch on that log base. So hit math, go down and get your log base. All right, so my base was at 3. The result was 3 to the 4th. So do 3 exponent 4. All right, y'all. So it basically looks like what they had. So now once I hit enter, notice I get a 4. So just remember, when the bases match, when this base matches that base of this, it's always going to equal that exponent, okay?
I did it wrong.
Oh, what happened?
I input on the calculator wrong. That's why I got a emailing.
Oh, okay, yeah. Yeah, so just put that base in there first and then put that 3 to the 4th.
Now, Mr. Eugene, a lot of them problems that you did like that, it wasn't the log ones. Oh, I forgot which one it was, but I was having such a hard time. It would be times where I got the right answer, but if you don't do it, like, okay, you see how that's a bottom 3? Like, what is those called? They're called bottom exponents.
That's the base. That's the base of the log.
Base of the log.
Mm-hmm.
Okay, because math lab is like super duper picky on how you put that in there.
Yeah.
Like if you do not.
So what I would do to put these answers, well, if you had these log answers, you would write log first.
Right.
And then you'll see MathLab has a little box down here
Yeah.
that's blue. You click that box to put in the base. Then you got to arrow back up to put in anything that's left.
Okay, but on the exam, I feel like are you gonna get that's something that we ain't gonna be able to undo, is it? Because that can't like that matters. So that's not nothing that you would say. Is that something you would say, hey, if MathLab say it's wrong, let me know and I'll
So yeah,
How
I
is
give
that
a
gonna
lot
go?
of credit on this as long as you got the right stuff that should be in here.
Okay.
Yeah. Yeah, because it's tricky. Y'all always mess up on putting the base and then getting back up to do the other part of it.
Yes.
Yeah.
Okay.
So yeah, if you got the right stuff, I'm pretty lenient on that.
Okay.
All right, y'all, let's see what this one will give us. So go back to that log base. So math, I'm gonna go down to log base. Now, anytime that result is smaller than the base, you gotta expect a fractional exponent. So
1/4.
oh, what y'all just get? I think it was right.
1/4.
1/4. So once I put in that, now remember, it's going to give me a decimal, but I'm going to hit the math and enter twice, and that'll turn it back into a fraction. And y'all, there you go, 1/4. So that one, MathLab does want fractions on it, okay? And you'll see on the answer blank, that one actually says right up under it, type of fraction. All right, now this one should be easy for y'all. Log base 40 of 1. Now check this out. I don't care what this base is. If that results a 1, there's only one exponent that I can put here that'll make that a 1.
0.
0, there you go. And y'all, you can punch it on log base once again, and log base is going to give you a 0 for that one, okay? So remember, no matter what your base is, if the result is a 1, the exponent has to be a 0. All right, y'all, then they want us to start converting. So they want me to convert to a logarithmic equation. So they'll have 2 that we're doing into logs, and then they'll have 2 that we're going to do to exponential. So for this one, I got 10 to the 4th equals 10,000. So to write it as a logarithmic, I got to write my log down. The base of the log will be the same as the base of the exponential. So since the base is a 10, the base of your log would be a 10. The result is 10,000. And that's going to equal the exponent, which is a 4. Now, 9 is doing the same thing, so let's see how y'all do this one. So we're going to convert to logarithmic equation again. So y'all, let's see what y'all do on this one. I got e to the -3 equals r. So I'll write the log. So the question is, what's the base of my log going to be?
10.
What's my result going to be?
-3.
Oh no, I heard someone say it, not the -3, but the r. And then remember, that's going to equal the exponent, which is -3.
Oh yeah.
Okay. Now, MathLab will be picky. A little r has to be a little r on your answer, okay? But y'all, let me ask you this. You can rewrite this one another way. Instead of using log base e, guess what I could use? I could use the ln of r equals -3. It'll take either way, okay? But remember, ln is a log base e, okay?
So are ln and log the same thing?
Well, remember, just a regular log like that without a base, that would be a log base 10. Remember that? Now, if we have a log base E, we just call that the natural log, which is the ln. Any
Okay, I
other,
got
any other log has to have that base written on it, okay? All right, y'all. Now we're going to go the other way and we're going to convert from logs into exponential. So convert to exponential. All right, so for 10, I got log base 5 of 625 equals 4. So remember, the base of these exponentials are the same as the base of the log. So since that's a base 5, 5 would be my base of my exponential. The exponent would be what?
Would it be 4?
It'll be a 4. And 5 to the 4th is going to equal the result of
625.
625. There you go. All right, so then they had another one, convert. Notice they're going to give you one with all numbers, and then they start trying to throw the alphabet at you to see what you do with those. So it's another one, convert to exponential equation. But we learned all this because we got to solve those equations at the end of this chapter, okay? All right, y'all, so let me see what I got here for 11. I got a log base little n of a capital T equals a negative y. So the base of my exponential equation will be the n. The exponent. What would y'all put for my exponent?
Negative y.
And that's going to equal
T.
capital T. Now, y'all, this one is really picky. Lowercase, lowercase, that has to be capital, okay? So that's one thing that it's really picky on is putting the letters in right. Oh, y'all, let me see. Number 12 actually wants us to use a calculator. So for number 12, it says use a calculator. And we're going to approximate this 4 decimal places. So any of the logs, when you're approximating them, it does have to be 4 decimal places. And they want us to approximate the ln of 910.8. Well, right on the front of that calculator is the ln button. So y'all, let's go use our calculator here. I'm going to clear all this history off. All right, so ln is right next to the 4, so hit ln and then punch in 910.8. And y'all want to hit enter. So let's round that 4 decimal places. That's going to be 6 point, what would y'all put?
8143.
8143, there you go. So the 3 didn't round up because it had a 2 following it, y'all. So be careful on your rounding on this. All right, y'all. Now, the next few questions get into the properties of the logarithms. We had a product rule, a power rule, a quotient rule. So this is going to hit them rules. So this one says express as a sum of logs. So if I'm expressing it as a sum, I'm going to be starting with a product. So I got log base 14 of 14 times 196. Now, they don't want me to evaluate these and get a number answer. They just want me to write it as a sum of logs. So distribute the log 14 to each factor and write it as a sum. So I got a log base 14 of 14 plus a log base 14 of 196. If you go any further and get numbers, it marks those wrong on MathLab, okay? They just wanted it rewritten as a sum. 14, expressed as a product. So when they say express as a product, y'all, all they want you to do is bring those exponents down to the front and rewrite it as a product of that exponent times the log. So here you got a log base capital M of t to the 16th. So when it says write as a product, you're taking your exponent and bringing it down to the front so that this is 16 times log base M of a t. But y'all are used to bringing them exponents now by not bringing them down because we did that a lot of times in here, okay?
And these are the ones, Mr. Eugene, these are the ones I'm talking about. That, oh, yep, I'm glad you said that because what happened is, see, okay, that MT, is that M is like you said with a base, and then that T, is that an exponent or is that just there? Like, is that?
No, so
That's how they get me.
let me pull MathLab up for a second.
Okay, yeah, you do it.
Give me a second to pull
Okay.
that MathLab up.
Okay.
And we'll do the 14 that it has on it because it probably won't match mine, but it'll be the same type of problem.
Okay, that's fine.
Y'all, so let me get, I'm almost to the, I got so many links to go through. I'm at the Blackboard link now. So now I'm at the Blackboard link going into the class, getting my MathLab link. And then let me go down to, so this is test 4 review. And that was what, 14 I was on, I think?
Yes, 14.
All right, so let me share that screen now. So are y'all seeing my new problem, log base 2 of y to the 19th? Are y'all seeing that?
Yep.
Okay. So for this one, we would bring the 19 down to the front. So I'm going to punch in my 19 first. Then I'm going to write log, L-O-G. And see, it got bright, so that means I did that part right when it gets really bold like that. Now, I'm going to go down here and get that 1, 2, 3, 4, 5. It's the 7th button I'm about to push that says subscript. I'm going to punch that one to put in my, punch that one and put in my base of, what is that, a 2 is my base. Now, I'm not going to hit the exponent. I'm going to arrow right. Once you arrow right, it brings the cursor back up in line with the log, and I'm going to put my y. If you hit the exponent button on the 2, although it looks like it's in the right spot, it counts it as an exponent and not as a result. Okay. All right, so y'all with me on that?
Okay, yeah, I got you. Okay, so you just arrow. It's not an exponent.
I
Okay.
just arrowed over using, there was 4 arrows on your keyboard there.
Okay.
So let's write this one down and I'll show you how I would put this one in. Log base C of x to the 6th, y to the 5th times a z. So let's work this one real quick and then I'll show you how to put it in. So y'all, since these are being multiplied like these ones up here that are being multiplied, you write them as a sum. So to distribute the log C to all three of these factors. So you'll have a log C of x to the 6 plus a log base C of y to the 5th plus a log base C of a z. Now, before we put the answer in, we got to do one more thing to this. What would y'all do next?
It wouldn't be look for like terms, would it?
Oh, no. But there's one thing I'm going to do that involves this product stuff.
Oh, are we gonna put it in the right order? Okay,
What?
I'm done.
No, I'm not changing. What would I do with these exponents? How about that? Oh, y'all done slept over that.
Oh, you'll put them in front. You'll put
I'm
them in
gonna
front.
put them in front. There you
Yeah,
go.
yeah.
So the exponents got to come to the front. So I get a 6 times log base C of x plus my 5 times log C of y plus my log C of z. So let's go put that in and I'll show you how that goes in. And then that should fix you on these type problems. So I had 6 log log. Then I'm going to hit that subscript button, put in my C, arrow right, and put in my X. Then I got a plus, and then I'm going to do all that again. 5 times log, hit the subscript again, put in my C, arrow right, put in my Y, and then I have a plus. And the last one was just log. Go down and get your subscript, put in the C, arrow right, and put in your Z. So that's the trick to those ones, making them look like your answers, okay?
I think my brain overthought those a lot.
Well, I ain't gonna lie, it's tricky putting them in because MathLab does not give y'all any instructions on those logs. It just gives you an answer blank and wants you to figure that out. All right, so 16 is the one I had y'all put a star by when we was doing this problem in class. And they want me to express as sums and differences. So I got a log base B of P to the 4th Q to the 6th over M to the 5th B to the 8th. So the trick on this is to distribute the log B to all 4 of these terms. And remember, if it's the terms were on top, they'll be positive, and the 2 terms on the bottom will be negative. So distribute the log B to everybody. So log base B of P to the 4th plus a log base B of Q to the 6th. So y'all, them 2 factors were on top. They were positive. Now we subtract the 2 factors from the bottom. So I got a log base B of M to the 5th minus my log base B of B to the 8th. Now, what would y'all do next?
Put the numbers in front.
Put the numbers in front. Well, 3 of these, I'll do that. How about that? I'll put a 4 here. I'll bring the 6 down. I'll bring the 5 down. But what does this equal? A log base B of B to the 8th. That log base matches the base raised to an exponent. So this whole expression is just going to equal that 8.
Oh, okay.
Because remember, this one matches, okay? So this will give me a 4 log base B of P plus bringing the 6 down and then log B of Q minus bring the 5 down log B of M minus that's just an 8. Because y'all, if you bring the 8 down, that'll be 8 times 1. Because log base B of B would be 1. So that's why we just write an 8 there. So y'all, here's the thing. Your problem will be just like mine. The only thing they're going to change are those 4 exponents, okay? That's all they ever change. I think even the base is the same every time. And it uses PQ and MB every time. So mark that just like we did. Positive on top, negative on bottom, okay? All right, then we get to simplify a few of these now. So 17, I got an ln of x squared plus 9x plus 20 minus the ln of x plus 5. So y'all, to simplify this, the first thing is to rewrite this as a single log. So bring out the ln. And this is just like this problem here. We're subtracting. So the positive factor goes to the top, the x squared plus 9x plus 20. The factor being subtracted, the x plus 5, goes to the bottom. So y'all, to simplify this, we got to factor the top of this. So the top's going to factor. Now the bottom only has the x plus 5, so the bottom's going to stay x plus 5. So y'all, let's factor the top. X squared to be an x and an x.
Oh, crap.
Plus 4x plus 5.
That's so plus 4 you said and plus 5. So then you're going to cancel out the x plus 5s, and your final answer will be ln of x plus 4. Y'all, it's very important. You got to keep the parentheses on this answer, okay? So we must keep the parentheses. Okay. All right, 18, simplify again. So 17 and 18 is where you're going to do a lot of factoring. Now this one has a log of x squared minus 3x minus 10 minus the log of x squared minus 4. So once again, you're going to write it as a single log, just like this one. So bring out your log. The x squared minus 3x minus 10 will be on top. On bottom will be the x squared minus 4. All right, since I got an x squared in the bottom, x squared in top, both of these have to be factored. So y'all on top, let's start with that. That's negative, so you'll have a positive and a negative. So what factors of 10 will give me a 3?
2 and 5.
Remember, the 5's bigger, so the 5's got to be negative like the 3. Now, the bottom, that's perfect squares. So it'll factor into conjugate pairs, 1 plus and 1 minus. So what's the square root of 4? We'll finish this one out.
2.
So that'd be what? X plus 2, x minus 2. So you see what's happening here, right? These x plus 2s are going to cancel. So our final answer is an x minus 5 on top and an x minus 2 on the bottom. This one, you do not have to keep the parentheses because it's a single fraction, okay? Now, we'll say some of these are multiple choice. 17 had a multiple choice on it to pick. 18 you actually had to fill in, okay? Now on this one, you don't have to put a base, you'll just write log and then hit the fraction bar and put in your answer. Oh, y'all, let's see. That puts us on 19 next. So let me get my paper. It starts to curl. So 19, solve for the x. They're giving us 2 to the 5x equals 8. So on these exponential equations, I try to rewrite this number using a base of 2 that matches this, okay? So can you rewrite 8 using a 2 as the base? And that'd be yes on this one. So bring down 2 to the 5x. So how many times you got to multiply that 2 to turn it into an 8? So let's see, we got 2 times 2 is 4. And then 4 times 2 is 8. So that would be 3 2s, okay? So on 19, rewrite the right side using the same base. Because look here, these bases match up now. And anytime the bases match up, that means the exponents have to be equal. So that means this 5x has to equal that 3. And you ought to solve that x now. I'm going to divide both sides by 5. So the 5's cancel, leaving my x. Can't do nothing to that, so that's going to stay a 3/5. So check this out. 19, you're going to be able to rewrite. Now 20, you're not going to be able to rewrite the right side. 20 has a 2 to the x equals 3. So y'all, think about this. When I couldn't rewrite this number using a 2, I had to do another trick. I took a log of both sides. So I did a log of 2 to the x equals a log of 3. We did that for one reason, and that one reason was so we could bring that x down to the front. So that I now have an x times log 2 equals log 3. Oh, y'all. So to make that 1x over here, I'm going to divide both sides by log 2. So x log 2 divided by log 2 will equal the log of 3 divided by the log of 2. These logs will cancel, leaving the x. Now, since we're dealing with logs, we got to estimate this 4 decimal places. And y'all, we're going to have to punch that in on the calculator, so let's go to it. Now, remember, I had a log of 3, so log of 3, close the parentheses, and then divide that by the log of 2.
It would be 1.58. You said we gotta do 4 decimals?
4 decimal places. So I like
1.584, no, 50. 1.5850.
Right, because that 9 turns into a 0, which turns that 4 into a 5. So good job. 1.5850. But that's the tricky part on this, is that rounding in a way.
I actually like rounding though. That was one of my favorite things
So if
to
you
do.
notice, this number 20 will be the log of this divided by the log of that 2 in the long run, okay? Y'all, 21, solve for the t.
You know what, Mr. Eugene, but I've always wondered this though. Okay, hold on, back to number 20.
Mhm.
Say, for example, how we got that answer. I just wanted to know this because it messed with my mind. Say it was 1.58. Okay, say instead of there being a 6 after the 9, say there was a 3. Well, we wouldn't round that 4, would we?
No, I would leave it just like that.
Okay, okay, it's right.
1.5849.
Got
Okay.
it. Okay,
Mhm.
yep.
Yep, perfect. All right, y'all. So this one I got e to the negative 0.59t. That's going to equal a 0.41. So 21, you're not going to be able to rewrite this using the same base. So on the e, when I got an e as a base, I'm going to take a ln of both sides. So the ln of e to the negative 0.59t will equal the ln of the 0.41. Now, this one will be different from what I had over here. Since I did an ln of an e, this is like a log base e of e to an exponent. Y'all, when you do the ln of an e, it's just going to equal the exponent on the left side. That's going to be negative 0.59t will equal the ln of 0.41. Because y'all, the ln of e part turns into a 1, and negative 0.59 times 1 is just a negative 0.59. So remember, the ln of e sort of gets rid of that ln on this side. Now, to finish this off, divide both sides by that negative 0.59. So that's going to equal the ln of your 0.41 divided by negative 0.59. So that's going to cancel, giving us our t. And once again, since I got an ln, we're going to round this one 4 decimal places. So let me punch it in and we'll see how y'all round it. So my ln of what? 0.41. Close those parentheses. Divide that by a negative 0.59. All right, y'all. So round me 4 decimal places.
15112.
There you go, because that's going to be what? 1.5112, because that last one
Yeah,
had
1
that
point,
8
yeah.
behind it. So good job. So really, it's the rounding you got to watch for on a lot of these, okay? All right, 22, solve again. So a lot of these we're solving toward the end. Now this one starts dealing with the log stuff. So I got a log base 3 of 4x minus 9 equals 2. Anytime you got a single log over here equal to a number, y'all, the only thing you can do to that is rewrite it as exponential. So your base is 3. So this is why we had to do them problems like 16 and 17, I think it was. So the base is 3. The exponent is a 2. And that's going to equal the 4x minus 9. All right, y'all. 3 squared. That's 3 times 3. So what's that? A 9 equals 4x minus 9. So now we're solving for x. So we're going to add 9 to both sides. Notice I get 18 equals 4x. All right, one more move, and that is to divide both sides by that 4. So I get 18 over 4 equals 4x over 4. So that side, those cancel, making 1x. Now, the math lab will take this 2 ways. You can divide that and actually get a decimal. So let's see, 18 divided by 4. If you do that on the
It's
calculator,
4.5.
you get
in the
4.5.
And the fraction is 9 over 2. Is it going to take the fraction?
It'll take this either way.
Okay.
So you can reduce that fraction and get a 9/2, or it'll take the decimal on this one. Under this answer blank, it don't have any restrictions.
Yeah.
Okay.
Okay. They even did a spinal injury and didn't hurt. I didn't think nothing of it. But this one, my reaction was just
Oh, shit. Oh, shit. What did you do? Partially empty.
You're a little live on that.
I was like, is she talking to Miss Eugene?
I'm trying to figure out what they were saying. I thought they were talking about my problems. Okay, probably not though, right?
I'm so sorry. I'm having to get groceries while in class, and that
That's
was
all right.
another customer here.
We was getting a kick out of that, I think. All right, y'all solve again on 23. I got a log base b. Oops, my bad. A log base 3 of b plus 16 minus a log base 3 of b plus 7. That's going to equal a log base 3 of a b. Well, y'all, the first thing you want to do on a log equation, you got two logs over here, so rewrite it as a single log. So bring out that log base 3. So remember, the stuff goes on top, that was positive, so that'll be the b plus 16. The stuff being subtracted, that factor goes to the bottom. That's going to equal to the right side, which is a log base 3 of a b. So this one will be different than this one, because over here I didn't have a log on the right side. This one I got log base 3 on both sides. So when the log base 3's match up, that means that the b plus 16 over the b plus 7 has to equal that b. Okay, so that was another property we looked at. When the log bases match, this result equals this result. So y'all, to do this problem, I'm going to put a 1 under the b to make it look like a fraction. And I'm going to cross multiply this. So take this b plus 16 times 1. That'll give me a b plus 16. On the other side, I'm going to take the b plus 7 and multiply both of them times b. So y'all, b times b is going to give us a b squared plus 7 times b is a 7b. So let's see. This is quadratic because of that b squared. So we need everything on one side equal to 0. So what you got to do now is subtract b from both sides and subtract that 16 from both sides. That way on the left side, I now have a 0. So bring down the b squared on the right side. The only like terms are going to be the b's. So 7b's minus the 1b is going to leave you 6b, and then bring down that negative 16. So y'all are going to be so similar to this. The only thing they ever change are the numbers up here, okay? All right, y'all, so now what we got to do is factor that. So that'll be a b and a b. That last number is negative, so you're going to have unlike signs. So what factors of 16 will give me a 6?
B plus 8, B minus 2.
There you go, 8 and 2. Good job. Remember, the larger factor has to have the same sign as that middle. So then y'all took both of those factors, set them equal to 0. So y'all, the first one, we're going to subtract 8 from both sides. And we get that negative 8. Second one, we'll add 2 to both sides and get b equals 2. So what are you putting in, Math Lab?
Positive 2.
Oh, good job. We cannot keep that
You cannot
negative
keep the
answer.
negative, yeah.
Because remember, y'all, since these are log equation, if you do a log 3 of a negative 8, it's going to give you, remember, we got them error messages,
Yeah.
and it said something like non-real result.
Yeah, no, real, yeah.
So when you factor that, only keep the factor. Basically, it's going to be whatever factor is negative up here, because that's the one that's going to turn positive. Okay?
Yeah, you just helped me remember these are the ones I can't stand.
So they little long and tricky, I ain't going to lie. But y'all's problem for problem will work out exactly like mine, okay? Like I said, the only thing they're doing is changing up some of the numbers on them. So watch this one. Log base 2 of x plus 3 plus a log base 2 of x minus 3. That's all going to equal 4. So when we rewrite this left side as a single log, these ones are being added. So that's going to be a log base 2. Since they're being added, we're going to write them as a product. X plus 3 times x minus 3. And all that's going to equal that 4. All right, so before we go further, we're going to multiply that. So bring down that log base 2. Y'all, these are conjugate pairs, remember. So since they're conjugate pairs, x times x gives you x squared. And then 3 times negative 3 gives you a negative 9. All equal to our 4. Now, this one will be like number 22. I've got a log on one side equal to a number. We're going to rewrite it as exponential. So your base is a 2. So let's ask this. What's the exponent going to be?
4.
It's going to be 4. And then that's going to equal the x squared minus 9. All right, y'all, so let's multiply that 2 times itself 4 times. So it's that 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 equals x squared minus 9. Now, y'all, I'm going to tell you the truth on this one. The easiest thing to do on 24 would be to move all the numbers over here and do a square root to it. So to do that, we're going to add 9 to both sides. And I get 25 equals my x squared. So y'all, we're going to now take square roots of both sides. So over here, square root of x squared will be my x. What's square root of 25?
Is it 5? I'm just guessing.
Oh,
Okay,
5 sounds
okay.
good. And guess what? I don't even care about the negative and plus stuff on this one. All I care about is that positive 5. Because remember, I can't keep the negative 5 anyway, can I? So remember, instead of doing the plus or minus on this one, you could put that here, but your only answer you can put in MathLab has to be a positive 5. All right, y'all, so number 25. And this would be like the last 3 problems you did in 9.7. The number of library books in a small library increases according to the function. So the function is B equals 7,400 E to the 0.02 T, where T is measured in years. So if they want to know how many books would a library have, so how many books would a library have after 3 years? So y'all, they're giving me 4 answers on this. So let me write the choices down and we're going to see which one y'all get. 7858. B is 9,042. C is 8496. And D, is 20,819. So y'all, here's what you're going to do to get that answer. You're going to put a 3 in for that T. So what you're going to punch in your calculator is going to be 7,400 E to the 0.02 times 3.
It's A.
So what you getting? 7,858 or so?
Yeah, it's 57, but then you're gonna round it.
Right, because it's got to be to the nearest book on that one. Good job. So y'all, I would punch into 7,400 like you did. And then I always hit second LN, and that gives me the E with the exponent, and then 0.02 times 3. And then because rounding it to the nearest book, that 5 kicked that up to, what did we say, 78.58, which was definitely A on that one, okay? All right, y'all, that's test 4. So here's my, let me remind y'all about this. So that was test 4 review. With the video tonight, I'm going to be sending a bonus for test 4. So I'm going to be sending this bonus for test 4 tonight with the video for this lesson. Wednesday, we're going to review for the final exam. Which means next Monday, I'll go over any questions y'all might have on that final exam. So next Monday, it'll be optional. And you only have to log on if you need more help studying for the final, or if there's anything else that's maybe bugging you for my course. Test 4 is due Sunday night, okay? The final exam, your final exam is going to open on Wednesday, December 6th, and it'll be due December 10th.
Okay, and we do have a Zoom next Monday.
Next Monday will be optional. So if you need more help, come on to Zoom and we can fix anything up.
Okay.
Okay. If you're good after Wednesday doing the final exam review, if you're good on it, practice that final exam a little bit before Monday. And if you need more help, we'll fix you on Monday, okay?
Okay, so you're just gonna you want us to kind of do the practice, and then Wednesday we'll go over any problems that we had on the practice. Correct?
Well, for this Wednesday, if you want to do it before Wednesday, do that. If not, I'm going to do all 25 questions.
Okay, cool. Okay.
Next Monday will be when, after I review it, then for sure try to do that review on your own. And if you don't do really good on that review, that's when we got to fix you next Monday.
Okay.
But if you're making hundreds on the review or something, I wouldn't worry about coming Monday unless you just got something else to worry about, okay?
Okay. All right. Thank you, Mr. Eugene. You have a good night.
All righty, y'all. So, let me tell you one more thing. You're going to see what we call a diagnostic for support class in there. It'll say something like support assessment quiz or whatever. We got to give you an assessment for the support part, but that will not count towards your college algebra grade.
And what's the assessment? Basically, like kind of like an exam over the support.
It's only 10 questions.
Okay.
And it's over stuff from the support course we learned this year.
Okay.
So here's the part about the bonus.
Mm-hmm.
On that support exam, diagnostics thing, it's got 10 questions. For every 2 questions you get right, I'm going to add a point to your test 4.
Okay.
Oh, thank God.
So that'll be how y'all are getting my test 4 bonuses, doing that diagnostic assessment, okay?
Okay.
All right, y'all. So let me quit my sharing here.